starting early this week. All right, so I'm going to go ahead and share my screen, and then we will just start going over these. I'm only going to go over 3 of them today. We're going to go over numbers 1, 2, and 4. Numbers 1 and 2 are calculator, and number 4 is a non-calculator. And I just want to, obviously give you guys some pointers on some things that I noticed on your test that you should probably start looking at also. But when it's a calculator question, even if the function's pretty easy, you probably should use your calculator. You guys spent maybe a little too much time on the test on that. So just keep that in mind. Utilize the calculator to the best of your ability. All right, so we're going to go over number 1 here, which is the grass clippings problem. And I went ahead and typed that function into my Y1, and that function is just represents the amount of grass clippings that remain in the bin before any decomposition. So the first question asks to find the average rate of change over the interval 0 to 30. Okay, so average rate of change is asking you to find A of 30 minus A of 0 over 30 minus 0. Okay, that's all that question is asking you to do. And you can do that in your calculator. Pretty simple. Once you have the function typed in, you can go to your home screen. And instead of saying A of 30, you can just say Y1 of 30. So I'm going to hit alpha F4, which is trace/calc button, or the 4th one on your function buttons at the top. And that menu comes up, and you just put Y1 and then put in parentheses 30. And then do the same thing for 0. So we're going to have Y1 of 0. And it's going to give us that number. But remember, that's just my numerator. So I get to divide by my denominator. I'm not going to type that in. I'm just going to say divided by 30. And that's going to equal negative 0.197 or 196. I also need to remind you guys on some of the tests that I graded, not everybody was going to 3 decimals. Okay, you have to go to 3. If you go to 4 or more, that's okay. But if you only go to 2, that's not okay. Okay, if it's a terminating decimal, 1/2, you can put 0.5. But if it's not a terminating decimal, you have to go to 3. All right, and the question also says indicate the units of measure. Okay, so this is the amount of grass clippings in pounds. Okay, it's measured in pounds per day. Okay, and it's a rate. Okay, it's a rate. That's why we have per day. All right, B asks you to find A prime of 15. Okay, and then interpret the meaning of the value. Okay, so A prime, remember, A is the amount of grass clippings in the bin. So A prime is going to be a rate, or the rate at which it's decreasing. Okay, so A prime of 15. There are several ways to find this in your calculator. Okay, we have that function input into Y1 right now. So we can go from our home screen and just hit math option 8 and then DDX. And then right here, we're going to put Y1. Give me 1 second. Is that me making all that noise, or is that somebody else? Can't tell. All the settings on my computer got changed while I was on break. All right. Anyway, all right. So now we're going to put Y1 right here. So that's alpha F4, Y1 at 15. Okay, and we type that in, and we get an answer of negative 0.164 or 3. You can truncate or round. Okay, and it asks you to interpret that meaning. Okay, the meaning of that is you have to say these things. You can't just say the amount of grass clippings that are decreasing, okay, or the grass clippings are decreasing. You have to say at this specific time. So at time t equals 15. Okay, we're not sure if that time is it is measured in days, isn't it? I can't remember if it says it. Yeah, in days. Okay, so at time t equals 15, the amount of grass clippings is decaying. Okay, we know it's decaying at a rate. Okay, and that's obviously a key word there. Okay, because this is a rate, it's a derivative at a rate of 0.164 pounds per day. Okay, don't put the negative here because we've already said it's decaying. Okay, decaying indicates that it's decreasing. Okay, so we don't have to put, and I'm using the word decaying. I think they may have said decreasing up here, but decaying, decreasing, or decomposing is the word they used. All right, the last one says for times greater than 30 days, L of t, the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. So we're actually going to switch to a linear function. This one was originally an exponential function. Okay. Use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. Okay. So L of t is the linear approximation, which means we need to write the equation of the tangent line at t equals 30. Okay, so there are several things you need to write the equation of a tangent line. The first thing is you need a point. Okay, so obviously at time t equals 30, we need to know how much grass clippings are in the bin. Okay, so we can go here and we could go to our graph, and I got it right there, already put in the window from 0 to 30, and we can trace at 30. And it tells us it's 0.78 2927-ish. Okay, so we're going to call this 0.783 or 29. And there's our point. Okay, we need a slope. Okay, a prime of 30 is, okay, so I can go back to my graph and find the derivative at 30. Okay, so that's under calculate. So it's second trace or calc, and it's option 6, finding the derivative. When you get back to the graph, you want to type in where you want the slope. We want it at 30, and we end up with a derivative. It's the top number here of negative 0.055 or 0.56. Okay, so I'm just going to write 0.56, round to 3 decimals. Okay, so the question is, use the linear approximation to find out when there'll be a half a pound of grass. So first we have to write our equation of our line. Y minus Y1, 0.783, is equal to our slope, negative 0.056 times x minus 30. And we want to know the time when there will only be a half a pound. Okay, y represents the amount of grass clippings remaining in pounds, so we're going to plug a 0.5 into y. And solve for x. Okay, you have a calculator, so none of these calculations should be a problem. I ended up with approximately 35.054, depending on where you rounded your actual numbers in your calculator. Okay, there is leeway on that. Okay, and this is days. Okay, I don't know if it asks to indicate that predict the time. I would say it. If it says predict the time, I would indicate the unit. All right, do I have any questions on that first one? All right, number 2. All right, we have a particle moving along the x-axis, so it's moving horizontally. The velocity of the particle at time t is given by, okay? So the first thing I'm going to do is I went ahead and put this in my other calculator, but I went ahead and put that function into y1, keeping in mind that this is velocity. So even though I have the derivative of y1 and then the derivative of y2, I'm not going to need this because we do not need the third derivative here. Remember, velocity is the first derivative of position and acceleration is the second. Okay, and the particle is at position x equals 2 at time t equals 4. That's actually not important to us. This is just a piece of a question that was given on an exam, and parts of it we don't know how to do yet. And the parts with that is what we don't know yet. Okay, so we're not going to worry about that, but this is an initial value is what this is called. Okay, at time t equals 2, we're or at the position at x equals is at x equals 2 at time t equals 4, initial value. Again, we don't need that. All right, so at time t equals 4, is the particle speeding up or slowing down? We had a question like this on our test, okay, and the key to this whole thing is you have to know how to determine if it's speeding up or slowing down, okay? Speeding up is when acceleration and velocity have the same sign. Slowing down is when they have opposite signs, okay? So on our test, I believe I can't remember what you were given, but I think it was, you had to find acceleration and it was negative. And I had a lot of people say it was slowing down. It was slowing down, but it was not because that the acceleration was negative. It was slowing down because you had to also find the velocity, which ended up being positive. And if they're opposite signs, it's slowing down. So you got the correct answer, but not the right way. So you lose points for the justification on that. Okay, so to find out if it's speeding up or slowing down, we need to find the velocity at time t equals 4 and the acceleration at time t equals 4. Also, I indicated this on your test for some of you that missed it, is you need to actually write down these values, okay? You can't just say acceleration is positive and velocity is negative. They need to know the values, okay? And especially since it's a calculator problem, okay? So to find the velocity at time t equals 4, we have the velocity graphed in y1, okay? It's there. That's going from time 0 to, I think, 5. Okay, I want to know at 4. So this is the velocity function. So I'm just going to trace at 4. Okay, and I end up with 2.979. Okay, that's my velocity. And now I'm going to find my acceleration. Okay, I could either go back into y equals, graph the acceleration function, turn off the velocity function, and trace there at 4, or I'm in velocity, I could just find the derivative at 4, which is the acceleration. So that's what I'm going to do. Okay, so I'm going to go second calc, option 6, which is the derivative at 4, and I get a value of negative 1.164. Okay, so now I can answer my question. Okay, I am slowing down because velocity and acceleration at t equals 4 have opposite signs. Okay, that's it. All right, part B says find all the times in the interval 0 to 3 when the particle is changing direction. Okay, the particle is changing direction when v of t equals 0, when the velocity is 0 and changes signs. Okay, you need to state that. Okay, it says justify your answer. That's the justification right there. Now we just got to go find those times. Okay, find all the times. Okay, so I already have it graphed, but I have it graphed from 0 to 5. So I'm just going to change my window and just look at from 0 to 3. And I want to know all the times where it equals 0 and changes signs, and it's only one time right here. Okay, so I just got to find that 0. So it's second calc, option 2. And if you're a cursor person, be a cursor person. If not, type in some numbers. I'm just going to type in between 0 and 3 because that's what the question is asking anyway. And there's only one of them. And once I do that, I end up with 2.707. So T equals 2.707. Okay, that's all you need. It's a calculator question. Okay, you justified it and you found the time. All right, by the way, this was from the 2016 exam, and it's number 2 on the 2016 exam. And if you'd like to see their explanation and how many points everything is worth and the rest of the question, you can look at that. But this was number 2016. I forgot to tell you, number 1 was from the 2014 exam, and it was number 1 on that exam. Okay. When you go to take the exam, number 1 and number 2 are always going to be calculator, and 3 through 6 are non-calculator. Okay, you get an average of 15 minutes per question. So when you take the exam, you'll get 30 minutes to do 2 calculator questions, and then you will put those away. Well, you won't put those away. You'll put your calculator away, and then you will have 1 hour to do the 4 non-calculator. Okay, and I'm going to tell you that you're allowed to still work on numbers 1 and 2 in the non-calculator time, but you don't get your calculator. Okay, so if you have to write out some justifications, or you just want to look at a few things, make sure you typed in the right stuff, you can, but you're not allowed to use your calculator, and you don't get extra time. Okay, so you just get the hour to work on the 4 non-calculator, and you can work on all 6 if you want. All right, we're going to jump over number 3, which is another calculator, and go to number 4, which is non-calculator. Okay, you're given a table, so we don't know the function. I can't remember if it was someone in your guys' class or if it was in my 6th period, but we were given a graph, I believe, and someone in their justification said the equation. Okay, we didn't have an equation; we only had a graph, so you can't say that. Okay, you have to use what you're given. So here we have a table. So if you're going to use the terminology of either graph, table, or function, make sure you're using the right one. Okay, so we have a table of values of f of x, f prime of x, g of x, and g prime of x. The functions f and g are have continuous and second derivatives. Okay, that's important to state that they're that they're continuous and have second derivatives. The table above gives values of certain select values of x. Okay, the function k of x is equal to the composition f of g of x. Write an equation for the line tangent to the graph. Okay, so we need a tangent line, which means we need a point and a slope at x equals 3. So we have the x value, which is 3. We need the y value. So we have to find k of 3, which is equal to f of g of 3. Okay, so we find g of 3 first. So we go to g of 3 and we get 6. Now we want to find f of 6. So I go to f of 6 and I get 4. So this whole thing is equal to 4, and there's our point 3, 4. Okay, second component of writing the equation of a line is we need a slope. Okay, the slope comes from the derivative. So first we have to find k prime of x. Okay, this is directly the definition of the composition of a function. Okay, it's in your foldable. The derivative of f of g of x is f prime g of x, and then chain rule g prime of x. And we need the derivative at 3. So k prime of 3 is f prime g of 3 times g prime of 3. And again, we're going to use our table. Keep in mind that this is G of 3. Okay, so G of 3 is 6. And F prime of 6, so now I'm going here, F prime of 6 is 5. Times G prime of 3, right out of the table, is 2. So we end up with a slope of 10. Question says write the equation of a line. It doesn't tell us what form to write the equation of a line in. I highly suggest you just stick with with point slope. Even if the answer key is in slope intercept, it's fine unless they, you could leave it in any form unless they tell you. So it's y minus y1, which is 4, is equal to m, which we got 10, times x minus x1. And there's your line. All right, and then now the last one is, now they're telling us h of x is equal to g of x divided by f of x. Find h prime of 1. First thing we need to find is h prime of x. And we have a quotient rule, okay? So that stuff doesn't go away. Quotient rule is bottom f of x times the derivative of the top, g prime of x, minus top g of x times the derivative of the bottom, f prime of x, over bottom squared. Okay, it's probably like 1 point for the derivative, 1 point for the substitution, and then maybe 2 points for the answer. Might be 2 points for the derivative, and then 1 and 1. Typically, they're worth 3 or 4 points each. All right, so now we're just going to plug in our 1. So it's f of 1 times g prime of 1 minus g of 1 times f prime of 1 all over f of 1 squared. And then you're just pulling numbers out of your table. F of 1 is negative 6. G prime of 1 is 8. Minus G of 1 is 2. Times F prime of 1, which is 3. And all over F of 1 squared. F of 1 is negative 6. Negative 6 squared is, negative 6 squared is going to be 36. So what do we have here? Negative 48 minus 6 over 36, which is negative 54 over 36. You don't have to simplify. They will take that answer. They will take this answer, okay? But they will. They might even take this answer, okay? But you can't stop here. You have to actually get these values. You got to do all that. You just don't have to necessarily do the algebra, but I highly suggest you do. This, by the way, was from the 2016 exam, and it was number 6 on that exam. Okay, the 2016 number 6. All right, do you have any questions on number 4 here? All right, we will finish up with the FRQs tomorrow, go over the exam, and then start going into integrals, which is the next concept of calculus. We've done all the derivative stuff for the most part, and then we're going to now get into integrals, which are antiderivatives. We're just going to go backwards. I have all your tests graded. Morgan, I got your second part. I just have to grade that, and then I'll put your grade in, but I did receive it. And then Sasha, I didn't get you. You were absent, and Abby, I did not get your test. So I need you guys to stick around, and I need to talk to you about that. Everybody else, have a great day. Don't forget that today is early release.
Thank you. Have a good day.
You too.